We have Mr. Funk and Mr. Livie.
Yeah.
Yay.
People are joining
Hello.
us. Hello. Yeah.
So, Eric and Daniel, you guys went over Sarah from like a subscriber point of view, like running.
I did a bit on the broker. I tried to do a little quick demo of.
Okay, you did that. Okay.
Like an SR watch, and then a Sarah, and then but it was like, I had two directories. I moved one file from one to another using watch, a broker, a Sarah, and a subscribe, right? So.
Okay, that's perfect. Yeah, so I figured I would like. Oh, I guess I should share. So I figured.
So Peter, just on Tuesday we went mainly through the first example, and that's why I made some of those note changes because I think it makes it more clear.
Yeah. So you guys should see the broker DDSR Science right now. Is that shared? I think I just shared that.
See your screen.
Yeah, so I figured I could give some overview so that people understand this. Oh, so Alex and Tyson have both joined us. Oh, Tyson's on mute. Oh, they're both on mute.
Oh.
Yay!
I have sound this time. Fantastic.
Hello, Tyson. Is that Tyson? Or
Yes, this is Tyson. Hi, nice to meet you, Peter.
Nice to meet you. Yeah, okay. Is that Alex who just piped up?
Yeah, that's me. How's it going?
I heard. Okay, Eric is here. No, Eric is not here yet. He's still on mute.
Is there?
Okay. I'm here. Hi.
All right. So I think we have a quorum. We have some people. So Eric, the idea. So I don't know. Okay. I heard that Mr. Funk and Daniel Pronich gave little tours on a little bit of the usage of Sarracenia. So I thought I would give a little look at the kind of the system view of like the way it's used and the volume of usage and that sort of thing, and then dive into what the source code looks like and maybe do a sample run of some of the testing suite that we have. And I figured that'll take about, I don't know, 45 minutes or an hour. And then we can spend 15. I'm okay until 4. I think I'm okay until 4. Let me check. Yeah, I'm okay until 4. So we could go a little long. And we could spend half talking about projects beyond. Like, it doesn't have to be about Sarracenia. It's just the neat thing about Sarracenia is that everything is public, and so it's probably easiest for Alex and Tyson to get access to that way. Does that match what you were expecting, Eric?
Yes.
Okay.
Yeah. Having a little trouble with my headset here, so you got just the computer audio.
Okay. Yeah, I'm using computer audio, and that's actually best for me. My
Same here.
Way better. I don't have my I can put my camera on so people can see what I look like with my fabulous COVID haircut. Here we go. But I think I'm sharing. Do people see a RabbitMQ screen, like a management GUI? I think I'm sharing that.
Yeah.
Okay. So what I understood from Daniel and Eric Funk was that they showed you a subscribe. So you've seen like the user level view of trying to subscribe to data, and then Eric showed you how you would inject some data into the network and then subscribe to it on the other end. So those are two kind of user use cases, and that's great. I think when a user looks at this, they look at it and they say, wow, this is really complicated. All I want to do is, why don't I just use wget? And And it's a fair point. It is a bit more complicated. One of the things that makes it make a little bit more sense is if you see how many transfers we're mediating at a time, how many transfers are going on. So if you look on this table, you can see there's 65,000 messages queued. So every queue, because nobody's partitioning their files currently, everybody is sending one message for one file. So that means there's 65,000 files that are queued trying to get somewhere right now. We're publishing on this, the DDSR science switch, 155 files per second. And we're getting, and there's 356 downloads going on right now. And I don't know if it goes back to 8 hours. If I can go 8 hours, I can show you some peaks. So you see the peaks here. We're doing 1.5 thousand messages per second. So, 60,000 per minute kind of thing. The math does work. So many, many tens of thousands of products go on. And in weather, the business, I don't know what that is. People hear that strange ring?
That's me. Sorry.
Okay, no problem. Oh, by the way, I'm recording this, and I don't know what I'll do with it in the end, but if it turns out to be crap, then I'll just discard it. But it's being recorded for now. We might just edit it and make something useful. So in the weather business, the way it works is they take in data and they run weather models at certain times of the day. And it's usually in UTC. I'm not sure what the, no, this is in local time. So what happens is you get these big peaks when the model finishes and it sends out hundreds of thousands or millions of products out. And the weather business, generally 2-day-old weather forecast is no longer a forecast, so it's very useless. So the general emphasis in weather data is to get data consumed as soon as it's produced. And so that's the whole reason behind Sarracenia. And I don't know, they're less popular now. There used to be, people used to talk about web push technologies. And when you delve into the technology of web push, you find out it actually isn't web push. It's actually web poll. So there are standards called RSS and Atom, and the way those work is they either maintain a database of what was published, or they put little XML files, and then every client is supposed to come in and poll and say, what's new for me? And they'll get a list. And so what they call push is actually every client who wants to subscribe polls and asks what's new. And so it's not true push. And if I mentioned the company, but there's a German company who saw, like, what they were originally doing is they would do like Beautiful Soup or something. They would come in and they would scrape the website. They would say, okay, my file that I need that shows up twice a day isn't there yet. And so they would just, check, and it's not there. And then they'd come back a few minutes later, check, do a listing, directory listing, it's not there, and go away. And so they would do this polling traffic all day because they really want the data. And so the total bandwidth they were consuming for that over the day was 90 gigabytes that they were polling from our website. And we switched them over to AMQP, and they went from 100,000 hits per day to some number that was too low to measure. And they went from 90 gigabytes a day of traffic they were downloading to 60. And the 60 they were downloading was what they actually needed. And they got what they needed faster. And so 30 gigabytes was just this polling of the directory to see what wasn't there, because they wouldn't go retrieve it. And then, and so that's what Sarah is about. It's about making continuous real-time data feeds work efficiently. So here we are. So github.metpx is the main website for all the open source work that we do under the, so METPX is Meteorological Product Exchanger. The main tool with the most activity is Sarracenia itself. So that's the Python thing, and that's what all your demos were done in. And it's the most heavily used one. SR insects is a whole bunch of test cases, and I'll go and I'll walk through a use of SR insects. So it's written in Python. It actually works in 3.8 as well. It's GPL licensed, so open source. And I wanted to point to the build fail because that gives us a link to Travis CI. And yeah, these tests are not reliable. So I'll just trigger a restart on that one. But this is just to say these are all tests that come from SR insects. So if we go and whenever we do a commit to the Sarracenia tree, it's hooked into Travis for continuous integration, and we run these tests. And I'll just go and I'll show you the job stuff. And no, where's the script? Config, is that what it's called? Yeah, so it invokes dynamic flow and flaky browser and stat. These are all names of tests. And so if I go here into SR insects, you can see these are the names of test suites: static flow, flaky browser, dynamic flow. Samples is where the sample data is stored, and tests is some unit tests. I don't remember exactly. So this is all stuff that so the main code is in the Sarracenia module, and the main integration tests are in SR insects. Now, the thing with these tests is they're really integration tests. They test a lot of components working together. The unit tests are in a bit of a strange state at the moment. There's some unit tests for, I didn't get into versions. I'll talk about unit tests later. Anyway, so these are the tests. And we can go and look at a sample output of one that worked. Let's go do that. Here's one that worked. So, okay, so what Travis does, it sets up a little VM and then it runs a script you configure to configure the VM for what you want. We install Sarracenia and Sarrac. Sarrac is the C version, which does a subset of what Sarracenia does. And then we run, it in the static test. It produces 1,111 posts that are. It posts this tree of files that's in that's in the sample data directory that's in the insects module. It posts them and then.
Yeah.
Okay, so this is a lie. It's actually. Okay, it's actually, yeah, so it says post, so that was fixed. It's not coming from a foreign server, it's coming from a directory that's local, and it just posts the tree, and then it gets downloaded into another directory, so we mirror it to another local directory, and then in the place where we're mirroring, we put a watch. And so the watch will announce the files again, and then the files get sent by a sender, so a sender will look at a file, think it's local, and do an SFTP or an FTP to send it somewhere else. We send it to some place, and yeah, so probably that directory, and then we subscribe to it, or we can post again stuff. In this diagram, so the triangles are exchanges, the circles are configurations, the red thing, the red rectangle here, that means these are both posts. So this is an SR post with a config TDD1, and it's reading from xpublic, except posts don't read, so this part is wrong. It should be fixed, but I'm not in a place where I can write. But they post to Sarah, and then the Sarah will download, and all kinds of entertainment happens afterwards. So basically, this config tests all the components with a bunch of different options and tries to break things. And so if you make a change in the code, it is very likely to tickle something. So the single, sometimes it's called the single flow test, sometimes it's called static. The reason it's called static is because we start with a directory tree with a fixed set of 1,111 files. And so we can check that to the last item that everything is perfect. We're using the same static data set every time. And the other reason it's simpler than the dynamic is that we use like one process here for everything you see here is just one process. This is a simple test of all the components. There's when we go, oh, now I have to switch what I'm posting again. So yeah. So this diagram is available, and we can. I'm not sure if it's helpful, but that's what it is. So the diagram is here. It's in static flow doc. But if we go to SR insects, remember I was saying the sample data. So here's the sample data. There's a directory tree under here, and there's 1,000 real meteorological data files, and they're all full of crap. And the important thing is they're static. So the order when we do tests, we'll do static flow first because that's, well, there's a test. We'll do the unit test first. So that's just within modules whether they work with themselves. Then the static flow is the first kind of integration test, and that's the simplest one. And the static flow that I just showed you with the diagram, it posts all the data in this directory that's local and copies it multiple times on the local laptop, or so that you using the different components and routing through a local broker that you've installed. The flaky broker is then a robustness thing. It's exactly the same as the static flow test, except we kill the broker multiple times while the test is going on. And the idea is that it doesn't lose too much. And ideally, it wouldn't lose any. Let's just go see. So the flaky broker did not pass last time. So this one is the dynamic. So the 1,000, 2,000, 3,000 ones, these are, instead of taking a local data set, they actually subscribe to the data mart at real time, and you have a real-time flow of data going through. And with this one, we take 1,000 messages. And in this one, we have multiple processes. I think that some of them have 3 in each component, and other ones have 5. So rather than being one process working on a task, it's 5. So you can see, like in this case, they got 1,023 messages from one side, 1,025. So there's 2 shovels going to the same server. Then it gets winnowed. So it takes the sum of these 2, which is 2048, I hope. And then half of them should be duplicates because they're both shoveling from the same source. So you end up with 1,018 coming out of it. And those 1,018 should then be downloaded and then processed by the later steps. And the later steps are mostly similar to the static, except there's multiple processes collaborating on the downloads instead of just one. And there's also these clean things. So the clean is this fascinating thing where it actually takes messages and puts them back at the watch. So if your clean ever breaks, many things break along the chain. But anyway, this is a good clean test. You see all the numbers are, this is clearly double of, well, it's exactly double of 1,018. So these are pretty clean results. We do have a problem where the tests don't run very well in the terms of they're not reliable. If you repeat them, they will come out okay, but that's why we can fire that one off too, and it should clean itself up if you resubmit it enough times. That's actually an open problem with which, if somebody feels they have some ideas, then we'd be glad to have that problem fixed. But it's fairly brain surgery like. Okay, so this is the test suite.
I got a question about the tests, if you don't mind.
Sure.
Is it possible to run them locally?
Yeah, in fact, that's what we want you to do. Different people have different attitudes. Like I have one developer who doesn't like running tests locally, but it might be because he has all kinds of problems with his laptop, and so they don't run very well. But yeah, later in the thing, I'm going to show you, and I usually the Travis thing is like an afterthought. I run it locally, universally. People know what GitHub is. I'm assuming people know what Git and GitHub is. Is that a safe thing to do? You guys?
Yeah.
Okay, so I have a couple of different branches checked out. This current stable branch is master branch is what I refer to as V2. So I'll go into V2, and so this is Sarracenia. This is the Python thing. And this is what it looks like. There's not much Python in the root directory. The guts of the thing are under the Sarah directory, and so you see this is where the source code is. And under there's plugins, and there's a I don't know, thumb in the air-ish. It's about 150 plugins maybe. And the thing with plugins is the users. Okay, like I talked about the volume of data transfers that's going on, like hundreds per second, thousands per second at peak times. But there's also several hundred to several thousand plugins that are implemented by the analysts, because our clients, like, client A wants the file name to be one way and client B wants a different file name, and they absolutely need the file name the way they need it. So we end up having to write plugins to change many times to change file names for a given client. So there are thousands of those. The plugins that are in here are kind of examples and meant to inspire people who need to write their own plugins. So this is what plugins look like at version 2. So if you're, this is an Ubuntu system. Oh, why did I do that? Yeah, I meant to do grep Sarah. Okay, so I've got Sarah. I got the 3.0 thing. I'm gonna downgrade. I have 2. So the latest version in this one. This is the latest stable-ish version that people are actually using. So, or you guys want? Okay, so to build the package, oh, I'm in here. So here's how I build a package. I do to build -us -uc, and that builds a Debian package from this source tree. And you can see yeah. So you see this is the file, or this is the file it built. So then I do sudo, and I'm installing it. So now if I do dpkg -l of metpx Sarracenia, you can see it's installed in a system way. All the plugins are there, and these are the binaries. So when Eric was giving you demos, he was showing you SR watch, and Daniel was showing you SR subscribe, and I imagine Eric also. So these are the components the package is built. And so then so now we have the right package installed. I'll go to insects. So this is git status. This is a checkout. Oh crap, I'm on V3. Is that a problem? No, it should still work. Okay, so I'll go into, say, tests. And I do, so they all have the same scripts to run. You do flow setup. And these are just unit tests of the modules in V2. And so you see the tests passing. Bum. We'll let them go. They should all pass. There should be no suspense in this, I hope. So yeah, so these are unit tests. This is all V2 stuff. Now the thing is, the V3 is a rewrite, and none of the tests have moved over. So this set of tests is useless if we're working on V3. I'm just going to do my window title to something that makes sense. Okay, and then we'll do a static one. So for V1, for the unit tests, none of the other stuff applies. So that's it. Here's the static flow. You do flow setup. So it's now, so I have a local broker installed on localhost, and I can show you the instructions. The instructions are in the dev manual. Have you guys found the developer's guide on GitHub? Does that make sense to you if I say the development guide? There's instructions. So there's instructions there on setting up your local broker and stuff. This is okay. This failed 3 out of 4. Oh, for static? For static, it should be clean. Why is it complaining? Where's the failed? Failed to start FTP. Oh, well, that's odd. Oh, crap. I've got 2 of them. So I was running some other test, and I just have to stop the other one. Hang on. Let's see. So you run the test. So then you do the setup again. Yeah, setup. This time it should be clean. So when you're doing the static test, it should always be 4 out of 4 on the setup. If it isn't, there's actually, oh, there are 15, but there are 60. Okay, more than enough queues is probably not a problem. You see, I'm looking at this failed here, so it's going to say 3 out of 4, but that's not a real problem, I don't think. But somebody should track that down. So then you do a flow limit. It's the second element. And so what that means is run the test until, so this, the original, the daddy test was the dynamic test, and the dynamic test can be any length you want. It doesn't, and so after it ran for a certain amount of time, you had to decide how many messages you wanted to run it for. So that's where all the scripts came from. So now we're posting 1,111 messages, and then it's going through that whole chain of components that I described that was in the diagram. So now it's finished posting them, and I can do a flow check. And you see, that's lovely. That's perfect. Does that count as a local test? Is it Alex asking the question, or Travis? Oops, I got the wrong name, didn't I? Tyson. Was that you? Was that you, or was it Alex who asked about running it locally?
That was me.
Okay. So
you just need to have a local broker installed.
Yeah, and there's a dev guide that shows all the setup stuff. Like you can install RabbitMQ on your thing, and you set you have to. I'll go find it. Hang on.
I'm fairly sure I've taken a brief look at it, but I don't think I ever got to the broker part.
Okay, we'll go over it briefly. Okay. No. Okay, never mind. GitHub. Yes. Go there. I go there. I go there. Come on. Okay. So running the flow test. So this is it. So yeah, those are the tests that are running. Consult. We had a francophone working with the docs. Okay. So yeah. So it says, oh Oh yeah, this is just how to install Sarah itself locally. But yeah, this is the thing you're talking about. You do install. So we're assuming Ubuntu. That's okay. If you get a Linux thing, what you want is an Ubuntu. The best choice right now is 1804. I develop on 2004. I don't see any problems yet. I'm just waiting for it to bite me. But anyways, so you do apt-get install RabbitMQ server, and you enable a RabbitMQ management so you can get the GUI working. And so when it's installed, I have local, that's it. That's what I was looking for. So I have my own local queue, and you can see this is because the static test ran. I'm gonna go, you have to trust me. I'm gonna do flow cleanup on the side where I was running the static test, and watch a miracle will occur starting real soon now. And you can see that it's okay, cleanup is happening. There you go, some of them. And okay, one left. Come on, come on. You should go away. Come on. Okay, that's weird that there's one. So I think this is because I started a second test while one was running, and so one queue just stayed left over. But normally it should clean it up. So you can see it's completely empty now. And I'm just going to do the same. Okay, I'm going to do the same. So you remember in the other window I did flow_setup. I'm going to do that again, and you'll see it should be posting now on the local broker. And it only updates every 5 seconds. So we should see there you go. So you see it's posting, and if I go look at the queues now, you're seeing 730 messages here, 250. Okay, and so it's flowing through all the components. So yeah, the process to do that is, so you just follow the instructions that are here. And there's about a half a dozen analysts that have done this in the past, so it is doable. But the code does change, and I think everybody who's gone through it before has improved it and found things where they got confused. And I think Ben was the last guy to touch it, and so I think he's made improvements here. So if you find something wrong with this process, treat all the documentation as something that can be improved, just like Daniel did when he took you on the tour. He thought something wasn't great. You can, yeah. So as you noticed, this documentation is part of the GitHub repository. So all the documentation is managed the same as source code. And if there's something wrong that we need to change, you just make a pull request and we'll improve it. So yeah, once you've done this, you should have a local broker just like this that can run the test. Okay, it's done. It's done. So if I go back here and swap to V2 again, there we go. So you see it's, I don't have to do the limit because I know it's over. And it's clean again. We just ran it again. So the static test takes, I don't know, like a few minutes, 5 minutes on my.
Peter, I think we're missing the bottom. We can't see at least I can't see the bottom part of your screen. Like
Okay,
I can
hang on.
once you.
How about that?
Yeah,
that
me too.
better?
There we go. That's better. Yeah, perfect.
Okay, sorry. Yeah, do tell me these things. Okay, so this is the so I just ran the static flow test a second time, and you can see the results are lovely. All the numbers match, so that's very reassuring to the order obsessed among us. And this test takes about 5 minutes, and it tests everything in single tasks, and it's generally good. And you have quicker turnaround. And then if everything works here, if you've made a change and everything works here and it's still clean, then you have to do a cleanup. Sorry, I didn't hear. Somebody mumbled. I didn't. Nope, I can't hear. Is that Jeff? I can't really hear you. I don't know why.
I don't think I heard anything.
Oh, it's my son. Never mind. It's outside the earphones. Okay, so you can see it's cleaning up. If I run the dynamic test, it takes about 20 minutes. So I guess what we can do is I'll start it off and then we won't wait for it. We'll do something, we'll talk about other stuff while we wait for it. So here I'm in the dynamic flow thing. I do flow setup.sh and it's declaring all kinds of exchanges and it's running all kinds of things. Starting stuff, and we got 4 out of 4. I do flow limit.sh. So it's gonna, oh, looks like there's some debug input somewhere. Okay, so this one is set to take 1,000 messages, and so if I now stop sharing and then share my browser window again, and I go here, you can see, okay, there's stuff coming in. Can you see the whole browser window, or is it too big to? I'll make it a little smaller. Is that good?
That's probably fine, yeah.
Okay, so you can see, like, if you look at the rates, there's incoming 0.8 messages per second and stuff. So it'll run for, 10 minutes or so, and it'll finish. So things like, actually, we can go. Okay, well, actually, so I'm going to go back, and while it's running, I can show you stuff to look at. Oops. So that's running, and we don't actually have to, that's just waiting to kill stuff when it finished. So while it's running, we can go into, okay, so there is a standard, I think it's from the freedesktop.org, about how to put preferences in temporary files and stuff. And so the Sarah stuff is laid out according to that. So I guess you guys were already exposed to that. If you go into not enough hours, excuse me. So all the config files for all this stuff are installed in here, and they're all ASCII files, and you can go look at I don't know, Sarah/download F20, and it has the configs. That's fascinating. But the thing that actually gives you the most information is to go into cache Sarah log. And here are the logs of all the components. And because we're running a dynamic, so every process that's running has its own log. And standard output and standard error is redirected into these logs. So when you want to see what's going on, or if you broke something, you can just do a more of, so this is a subscribe by FTP. So we've got a local, one of the daemons that started up when we start up the dynamic test is an FTP server, and then we do anonymous downloads, and that's what this particular process is doing. So this probably looks familiar if you saw SR subscribe start up. SR sender, oh, this is a subscribe, never mind. So this is a subscribe, you can see this is the queue it's bound to with that binding. So all the messages in version 2 protocol or format from the exchange, this exchange, XTS post. And then there are plugins that do like statistics on crappy, small, simple statistics on the messages being downloaded, and it's showing you each file being downloaded. And if there was something wrong, you could see it here. And so this is all the stuff that's running, and this is how to find stuff that's wrong. And this is like one-stop shopping. This is the only place you have to look for error messages, because the standard output and the standard error is redirected. If the program crashes, you'll see like a stack trace in the log file. So yeah. So that's how you would see stuff. So I'll just go back to the source tree. Are we done yet? 5:34. We've only got half. Okay, so we'll just leave it. So yeah, so that's how the tests run. So you do setup to set the stuff up, then you do limit to have it stop at the appropriate time and to wait after it's finished, like there's cleanup and draining of queues to happen. And then once the limit has finished, you run flow check. And you could run flow check anytime you want. Like if I run it now, so the test is running, it's not finished, and I ran flow check while it was running. And this is normal, this result that you see here, these failures, because what pclean does is it fakes failures, puts stuff to the side, and that way you can try. There's a retry mechanism. So what it says is, oh, I can't get at this right now. I'm going to put this in the retry, and then the code is supposed to, on its own, recover that and eventually submit it for proper processing. So the pclean is always lagging, and you have to wait till the end. And I think there's a delay in the flow limit to wait like a couple of minutes after the end. See, it's still not there. And then it will succeed. It like it will drain and it'll catch up, and the answers will be okay. Now, oh look, see. Okay, so that's the other thing is the longer your test, the less statistically significant the delays are. So the more likely pclean will be okay. So you can just wait, and it's actually, you see the number. Oh, the numbers match. No, they don't. This should be 14 something if it was twice. So you can see yeah, so it does like a plus or minus 10% thing. So this is going to upset all the mathematically precise people. In the dynamic thing, we almost never get a perfect score. And we're reaching towards perfection, but we haven't gotten there yet. And there's much mystery there. But basically, we have a criteria built into the flow check to say if it's within 5% or 10%, or I don't remember the number, but within a certain margin, we call it good. And so the bigger the number of your test, the less behind the pclean will be in proportion to the test, and so you can get passes. Anyways, so the only time you should get really correct responses is after you've done the limit. Are we there yet? 883, still not there. Okay, so yeah, the idea is you do source code changes. Actually, let's go. Where's this grep? So the v2 flow star.sh flow include.sh v2 up that. Okay, there we go. Okay, 9:41. So another couple of minutes and it'll finish. And you can go and look at the logs anytime you want to see stuff that's busted. Everything is in. And if I do SR status right now, these are all the components that are running. So you can, well, oh yeah, this is a VE. So the C, these are the components written in C. This is Sarracenia stuff. Are you guys familiar with C? Do you guys want action in C, or is Python a good choice?
Either or. I like C quite a bit. I like Python too. It's fine.
Okay, so yeah, it's we're a best tool for the job kind of thing, and so C is used in certain. It's like a subset. It doesn't do everything that the Python one does. It's a lot simpler. And it's used in certain narrow constraints, but where it works, it's obvious. It's like 10 to 50 times more efficient to use than the Python, where you can apply it. But it's fairly stable now. Most of the action is on the Python side. So yeah, so ignoring the C components, so we have poll. So poll is a component where you go and you poll a remote server and you get a list of things to download, to notice, and then you produce messages telling other processes, hey, this is available. And then a download process like a subscribe or a Sarah will then do the actual retrieval. So poll doesn't pull any data, it just sees what's available. Post is similar, but for local files, it'll look at a directory tree and say what files are in there that are new and fabulous. Report is a component that, I don't know, it might even die. It's just a subscribe that doesn't download it. It's meant to provide like telemetry back to the source of data. So like you would subscribe to data and you would produce a report saying, I got this piece of data, and you would send it back to the source. The problem with reports is we have this thing where if one person sends one datum and there are 30 clients, then for the one message that goes out and gets consumed by 30 clients, they'll get 30 messages back. And so it turns out that the amount of message forwarding muscle that you need is at least as big. Like we need to double all our brokers in order to handle the report traffic. So we haven't deployed reports. That's not really used yet. Sarah is is a subscriber. That the only difference between Sarah and subscribe, like they're the same code. One inherits from the other. The only thing is that normally at the end of a Sarah, you would post afterwards. So if I look at in this file, you can see this all looks like a subscribe. We've got a broker. We're going to an exchange that we're subscribing to. We're suppressing a bunch of plugins. We're using an accelerator to use the C retrieval instead of using the built-in Python stuff. We're placing it in a directory and we're accepting everything, and we're using 5 processes to do it. And then this is the part that you wouldn't usually see in a subscriber. Once we've done all this and we've downloaded the file and we've put it in this place, then we post to this broker on this exchange, changing the base directory and the base URL to refer to the local server. So you're essentially spawning, you're cloning the source and claiming it as your own. So this part is the only thing different from SR subscribe. It's just to like daisy chain the feeds. So let's check out, is limit done? It's sufficient, yes. So now it's turning off the shovels from the, I think it's from hpfx.colab that it's pulling. So it's turned off, the shovels just move the messages around without downloading any data. They feed into a winnow. The winnow gets rid of the duplicates and then publishes the unified, the unique URLs to a Sarah or a subscribe to download. The subscribe is downloading, and so now they're going through the retry queues for these artificial failures. So so this will take another minute or two to stop. So this you can set up on any workstation you want, and you can reproduce this. At this point, you do need network access because we're going to hpfx.colab. I guess I can, if I stop and then I do this, and then I do this, and then I do that, I do that, and then I go there, and I do it there. Okay, http HP, there we go. Well, this is my private one. I don't want my private one. I want this one. So this is what hpfx collab looks like. You've got a root directory with just a directory per date, and when we run out of space, we delete the oldest directories, and then under there. So this is an external server, so there's only 2 sources here. On an internal server, you'd see dozens, 2 or 3 dozen different sources. Here, there's like a fake source, which I resent, called WXODD. That's a long, but this is the stuff we're getting for the tests. and you can go and see any piece of data that you want. I guess the smallest stuff, the easiest stuff to look at is the alphanumeric stuff. So let's go find the trusty SA. So SA is a surface observation. CWAO is Dorval, is where we work, the office in Dorval. And here is an SA. So this is a Canadian weather observation for CYBG. And if I go and look up, let's see, CYBG airport. Bagotville, there you go. So this is the raw data that makes that happen. They're decoding this stuff in this. This is a METAR is a meteorological report for airmen, and it says there's showers and overcast, and there are remarks that are anyway. So this is like a weather data thing. It's very old. This is like from the 50s, and they have new formats that are binary now that of course humans can't read, which is why they don't make a good example. So yeah. So yeah, when you run the dynamic test, you'll basically be pulling, there's an AMQP broker that's running here that's just like your one on your local server. And you'll be getting notifications of all the files being dumped into this, this tree on hpfx.colab. And that's what that is. So that's how you would run the tests. Okay. So I guess I could go and talk about the different source code versions now. Does that make sense for the tests? Do you think you, it's a challenge. So the challenge is it takes about a week or two, maybe, people to get their environment set up with the broker set up and they and able to run the flow test, and they've done all the Git checkouts that they need and all that. And it typically it's a half dozen developers have done it in the past, and they all got it done eventually. It was very painful originally. I hope and trust it's getting less painful as more people do it. Just gonna, so there. Okay, so do people see the flow test says it finished? It stopped at 1771.
Yep.
And then I can do a flow check. And it should be clean. Please be clean. 21. Damn it.
So Peter, what does limit 1,000 mean?
1,000. What do you mean? In
we stopped at 1771. One line there said limit 1,000 just before.
Yeah. So what happened was I started the test, and when I run flow limit, the flow limit is stopping it at whatever limit you ask it for, and the default limit is 1,000. And so if flow limit is invoked when you're already past 1,000, it'll just stop it right away.
Okay.
So 1771 is higher than 1,000, so it stopped it, and it just this is the process of stopping it, of completing it. See, they're taking the shovels from HPFX and they're stopping them, and then they're waiting for all the queues to drain and all the retries to run, and then they stop.
Oh, that's why we're exceeding 1,000, because everything had to finish.
Yeah. So then so it says that one of them failed because we've got too many messages there. Okay, that's weird. That is weird. I do not know what that is. Okay. Except maybe it was that strange. What? Yeah. What the heck is that? Okay, so I guess we can go look. Cache Sarah log. I go look in here. I'm just going to do head of that. When did this start? 1441. Head of, say, this one. 41. Okay, so it's not a leftover test that just started. So what is this then? I do not know what happened, and it would take some spelunking to figure out. I do not know. Post total. It might be a measurement thing. So I'm in a stream where I'm testing with V3 and V2 at the same time, so I have to change some of the metrics to work with V3, and then I have to go back and test them on V2, and I haven't done that recently. So this might be just my flow check got modified in a way that wasn't compatible with the old one. So anyways, but the idea is you run the tests. If they are dirty and you have, so first thing you want to do is run it like this, clean, and see that you get the clean stuff. If you don't get clean results to begin with, don't start modifying code because they won't be clean afterward. And if to explain what I mean, I'm working on a version 3 branch for the flow tests themselves. And so that's why I have some modifications that might have broken V2, and I don't have time right now to go back. Okay, so that's the tests, and the tests are the same no matter what version of Sarah you're using. So you run those tests, and everything should be clean. So if you look at the source code for V2, and you go into Sarah, this is what it looks like. Every file starts with SR underscore, and we've had other developers come in and they all pulled their hair out at how weird the structure was. And there's lots of things being done multiple times in the code, and there's lots of duplication of code, and it's painful. There's lots of like extra checks that we don't understand why they're there, or extra settings of variables that don't make much sense. And so if you look at WC minus L of SR star, you can see it's about 17,000 lines of this stuff. And I think, so over the years, over the last 2 years in particular, we've been looking at it, and there's things that we want to do that we just can't do with the current code, like adding. So AMQP is what you've been hearing about. Everything we've been talking about is RabbitMQ, but there are other messaging protocols out there. And while RabbitMQ is certainly a 900-pound gorilla in its own cage, there are other cages. And what we'd like to do is be able to communicate with whatever the message protocol du jour is. So one of the targets we had was to be able to use multiple messaging protocols. And like, it's all like, there's no modularization in V2 at all. Everything is linked together. So I had 2 or 3 different analysts all look at this problem and either resign in frustration or give up and ask for another task because it's just not doable in the V2 code. So to get it to the point where it's easy to do, you have to refactor the whole application kind of from to square one. And so that's what V3 is about. It's a refactoring. I'm way over time already, so I'll try to go in a couple of minutes. So V3, if you look at V3, oh, look, it looks the same. There's no difference here. Yes. When you get into the actual source code, you can see there's a lot of files that don't start with SR. Basically, anything that starts with SR is old stuff that we haven't transformed yet. And everything else is the new stuff. Well, I think this was there already, but it doesn't matter. So should I install it? I can install it. Okay, so let's just do that. So we should probably turn off the flow chest. Okay, I'll go back. So the new code, instead of having SR underscore this, it has a much more modular structure, and there's much better separation of concerns. So instead of like to add another protocol in the version 2 code, you would have to play with SR AMQP, SR cache, SR message, SR consumer, consumer, um, uh, SR instances. You'd have to play in a whole bunch of different places, and the interactions aren't obvious, and so it's a pain. So rather than do that, I would suggest that people work with version 3, especially if you have 3, you're going to spend 6 months understanding the code if you try to understand V2. But if you need to understand V3, then there are little bits that are much more modular. For instance, okay, so Sarracenia. Sarracenia is a carnivorous plant. What do carnivorous plants eat? They eat insects. So moth is something that a carnivorous plant would eat. What do they consume? Messages. So we have a messaging protocol, and so all of the AMQP related messaging in V3 is in this one file, and you can look at it. And this is to talk to a RabbitMQ broker using where's the library? Should be called AMQP. Using a library called AMQP. There are a bunch of different AMQP libraries for Python, but this is one. But the thing is, this is 450 lines, and I think a student has a chance of understanding it if they've got 3 months. This is the one that we use, and that is used for everything that happens right now. And the thing that we haven't been able to do over the last few years is add other protocols. Now, putting it into its own modules like this makes it really easy to figure out. And you can do things like so if you wanted to add a protocol, you would just add a file that does what this one does, but like the first one would be Pika, because Pika is another Python library, and you can just have it work exactly the same. Yes, Pika, Pika, Pikachu. If you go, where is it? So Google for Pika AMQP library, and you'll find it. And it's just a library that works different for AMQP, but it does the same job. And if I go into examples, this moth thing. So this is a complete example, and it's like 30 lines long, and all you do is invoke Sarah and the Sarah.moth.moth, and the broker URL tells you what the thing is. So if I let's see what happens. Will it break again? What happens? No mod. Oh, because I not have the right version installed. Okay, hang on. Okay, so I do debuild -us, as you can see. And I do debuild. I like working with Debian packages, but it's not an enforced thing. People can use pip if they prefer to use pip install -e dot kind of thing, install locally using pip, or and people using different environments kind of makes the thing more robust. I'm just installing the current dev one. Okay. So there. Ah! So you can see it's downloading messages from somewhere. Is there a startup message? So it's printing out the options first, then it connects to hpfx.colab.science. And you see the URL here is what triggers it to use AMQP. So the idea would be if you wanted to add a new so if I do amqp.py, there's a thing which says, where does it say it? There's a thing which says what URLs I am. Where is it? Crap, it's way far. There. So yeah, you filled it, and for Pika, I guess it would have been smarter to use the Pika one, because the Pika one is a stub right now, right? So what you would do is you would make instead of having AMQP, you would have like a URL broker would be Pika s dot hpfx.colab.science.gc.ca, and Pika the S for the SSL. And then you would have and then it would invoke the Pika module, and you would make the Pika module work just like the AMQP one. So all you would need to do is work in this one module and get the example to work, the example I just showed. There. So that's the thing. So this is downloading the messages and no data, just the messages from the broker. And if this works in version 3, then that means we can just use it. All the rest of okay, you wouldn't have done the publish, but if you get the client working, that's a huge step. We could probably come up with another example. So I think that's a self-contained thing that somebody who only has a few months could figure out. And if you have to look, you don't have to look at the rest of the code. Although you can, there is other stuff. The other thing is that the algorithm is much simpler to understand if you end up looking at the other stuff. And if you have to write plugins, I don't have time to explain, but the plugin logic is much more sensible in the new one. And in fact, most of the logic in these SR files is now in plugins. Like if I take SR post is now substantially implemented in a gather plugin gather file. This is where most of SR post ended up. And if I do wc -l of plugin gather file.py, it's 800 lines. And if you look at sr post.py, it's 1500. So we're able to extract duplication and simplify the code substantially in version 3. So when version 3 is ready, it will be a lot easier to work with. So I think that would be a promising development project to work with. So plugin is the version 3 stuff. Plugins with an S is all the version 2 plugins. Yeah. Anyways, so there's lots of work to do. It's going to be another month before. Right now, I have I can run the flow test on. So if you look in, go into sr.py. I go in here and I look for winnow. Say so. The shovel, the watch, and these components have all been replaced by the new ones. So when I have a component that's new, I invoke the new one in SR, and when I have an old one, I invoke the old one. So that way I can run the old and the new together, and I can still run the flow test. And I'm just gradually working through until I've replaced them all. So I can do, where am I? So this is running with version 3 now instead of version 2. And you see the output is quite different. There's lots of debug crap in here. This might or might not work because I was working on watch and I don't remember. It might be finished. The watch kind of works. The watch needs a reformulation because it uses recursion and it needs to become iterative. So there's lots of little bits of code that could be assigned in there. And that's version 3 stuff. And I'm way over time.
So Peter,
yeah?
I'm just wondering, we spoke about some other projects that you were potentially going to talk about. Do you want to briefly touch on them?
Sure. So did you have the list? There's the Iridium one?
Yep.
Um,
Iridium and a Podak.
Okay, Kodak. Okay, so okay, for both of those you'd be working with V2 and it would involve working with plugins in V2. Did I stop sharing or did I? You guys see the flow check? 10 out of
I see you right now. I think you stopped sharing.
Okay. Okay, anyways, the test is broken and failed miserably, so that's not a good thing anyways. Okay. I will share a work screen instead of a personal screen then. Hang on. Okay. So is there so the Podak, didn't we have this written down somewhere? The Podak thing? Was it in an issue? Do you remember, Eric?
I just have it. It was about replacing it with WebDAV.
Yeah. So I think there's an issue. So so the students don't have access to GitLab, right? Because it's internal.
Correct.
So they can't see it. So so there's this Podak. Does Kurt? Do you remember what Podak stands for?
I think Kurt's on the line.
Oh. So it's polar orbiting data, something or other. Anyways, there's this thing, and they have and Kurt did a first job which mounts a file system, and a lot of analysts recoil at the idea of mounting a file system because it makes the whole system, like it makes it a system thing instead of an application thing, and sometimes you can have the whole server kind of if a file system gets stuck. So we'd like to make it more of a poll, and the way to do that is to make an SR poll that uses WebDAV. So can you guys see I'm sharing the issue in on GitLab right now? I think.
Yeah, we can see.
Okay, so there are WebDAV modules for Python. Likely would be fun to have an SR poll plugin that uses WebDAV module to obtain a list of new files, and then use ordinary Sarah for downloads. So I don't know if this is gibberish to the students right now, but so you guys saw SR Watch. SR Poll is another thing. Instead of looking at a local directory, if it was FTP, you would do an FTP to a remote thing. You'd list the directory, and then you could find the files, and you create posts out of that. And it also works for to do some website scraping. So yeah, that would be one project that I think Kurt is the guy who knows the most about the Podak stuff. But I don't think anybody has worked with WebDAV before in Python. But that would be a project, and it would probably take a month or two. Whether it actually works or not, we don't know. I think it ought to work. It should work, but I don't want the student to be disappointed if it doesn't work in the end. So we're giving you an experiment to see, and it might turn out that what we're doing now is the best thing we can do, and we won't be able to put something his work in production. But on the other hand, we'd like something, that's a better fit if we can get it. Does that make sense to you guys? Do you understand what the ask is at this point for that project?
Are you asking the students who are still stumbling through this, or the people who have a better idea?
So yeah, I'm asking Tyson and Alex if they have any. If this, so the project here is to write a plugin script. I can show some sample plugins.
I've taken a look at some of the plugins that are in the Git repo.
Yeah. Yeah, so if you look at the poll email, I think there's a new poll email one, and it'd be something like that. It'd be entirely different, but similar in complexity and yeah. Let's go here. So typically we name things after what they do. So there should be a poll underscore something there. Poll U.S. Geological Service. Poll, I don't know what these guys are. Poll Pulse. Poll NOAA. So this is to get NextRad from AWS. So an AWS polar. So this was written by a student 2 years ago, and it was to get radar data from the Americans from AWS. And it works, sure. Wasn't there an email one? Yeah, poll email ingest. Here's another one. This is written by another student a few years ago, and these are all in use. These like, we're not giving you fun assignments just for laughs. We actually need this stuff. And so it made the messages, and then we pull the data down using a Sarra. So there are lots of examples. All these polls would be examples, and you'd have to write one that works for this other service. So that's probably a relatively tough assignment that would take the whole time that you have. One that might be simpler is, I'm just going to look.
How about the Iridium?
Yeah, that's where I'm going now.
Should I paste what you typed in before?
What I've typed in?
In the...
Okay, sure, go ahead.
I put it in the text.
Plugins. Okay, yeah. So Iridium. Okay, Iridium is a constellation of satellites that provide worldwide coverage because they're orbiting all over the place. Okay, that was very technical. Iridium they're polar orbiting satellites. So and there's multiple bands of them, so they cover the entire Earth, which is a huge innovation because the previous systems that we had, they just had geosynchronous orbiting satellites. So the geosynchronous ones, they're over a single point, 26,000 miles above the equator. And that's great if you're in the United States, but not if you're north of 60 latitude, because the curvature of the Earth gets in the way of your signal. And so in the Arctic, it's hard to get these signals from such things. So GMDSS, no, I don't know what that stands. Oh, there it is. Well, MSI is Maritime Safety Information. So we have there's a project about providing meteorological information about icebergs, about winds, about storms to ships navigating in Arctic waters. And most ships in Arctic waters can't get satellite signals from geosynchronous orbiting satellites. So the Iridium constellation was put up in the 1990s, and it's in its second generation now. And somebody's going to mention SpaceX, and that's great, but it's in the future. And SpaceX is doing their first band so that it won't cover the Arctic, which is kind of annoying. But anyways, the idea here is it's just an internet. As far as we're concerned, it's an internet. The thing is, it'll have really bad latency. Like very high latency still, not like geosynchronous, but still pretty bad, and very low bandwidth. So you don't want to be sending imagery and stuff over this stuff. So what's going to be sent is these little text messages of a few hundred bytes, maybe a few K at the most. And the idea is to transmit these to little receiver boxes that are canned hardware that will receive the signal and download the bulletin and put it in a special place. And so our job is we have to send to the transmission site the messages that we get from so our client is the weather service, the forecasters and stuff. They make a weather bulletin that's a few hundred bytes of, iceberg coming dead ahead 50 miles away from you. You might want to change course or prepare your glasses for ice cubes, whatever. And we take that message and we have to send it to the satellite provider so they can uplink it. And so this SFTP quick reference guide that I've got is it's a interface communications document, very simple version, where all we have to do, so marine safety information, there's this standard that defines this MSI stuff. And so these C codes are defined for us. We just have to talk to the domain expert, which is Tom King at an office in Gander, and he'll help us. And we might actually have this information in our existing stuff because we currently uplink to a geosynchronous orbiting service called Inmarsat. So that's all the context about the why. What we have to do, we have to take files, give them a special name, and deliver them to a directory at a service provider. That's it. That's the whole project. And for you, the project, and we already have something that sends files, so you don't have to send the files. All you have to do is take the file, whatever its name is, do some table lookup, and change the file name to match this MSI stuff. So this is an on-message plugin that you would write, and it would change the file name, and then we would deliver it to their uplink server. And that's it. That's the project. And this, we need it for August because they want to be operational to give mariners information about weather in their area by August. So the timing is great if a student could do this project. And it's really simple. You could do it manually to start with, and you could subscribe. You don't need the actual data that we're sending. You don't need, because you can just subscribe to HPFX or the Data Mart and pick other messages and rename them instead. Yeah. So that's the Iridium project. So understanding what you need to do is probably 2 or 3 weeks. Actually doing it is probably a day of actual code. That's the Iridium thing. Is that a? I'll ask Eric. Eric, is that kind of what you were talking about? Von Gravenitz. Narrowing down the Erics.
So was I talking about that? Well, you were talking about that.
Okay, so that's an on message plugin that somebody would need to write. And if we don't get a student to do it, then I'm going to have to task an analyst. So that's a warning to the full timers. if we don't get somebody to do this, then we have to do it ourselves, which shouldn't be a big deal, but people have to actually focus on it. So that's another project. So is that so? We've got the PODAC we talked about. We talked about the iridium stuff. Yeah, so this is the SFTP method. There might be another method where we send an email, and so in that case, instead of being an on-message plugin, it would be an on-file plugin, and you would modify an email as it went to add headers to it. But the purpose is the same. Our preference, if we're given a preference, is to use SFTP. We find that more reliable than email. There's all kinds of, our stuff can get filtered by junk filters and we're supposed to route it through the main government gateway, and the main government gateway can be affected by many things. So we would prefer to use SFTP.
Okay, so any of these plugins
Yep.
we would be building, would we want to do this on the version 3 implementation?
Yeah, no.
Okay.
No. You'd have to use version 2, because if we did it on version 3 is probably 6 months to a year from deployment. It's probably going to have a working version maybe in a month or two, a working version that we can start documenting and trying stuff out. So the version 3 stuff is kind of for the future. And the thing is, it's easier to write. I think it'll be way easier for you guys to write code in the version 3 stuff. But the problem is, it's not useful to do it yet. Because the actual stuff we have deployed for many, many months will remain version 2.
Okay. No, that makes sense. And then afterwards, if it needs to be ported, I don't think that'd be a big job.
Yeah, no, it's not. Well, okay. Porting the plugin infrastructure changes completely from version 2 to version 3. But it's yeah, but don't worry about it. There's a wait, I'm here. Hang on. I can do okay. So yeah, I was going to demonstrate on the supercomputer we have where the C stuff is running. But anyways, if I go into where am I? So one of the first plugin and the hardest plugin to write was the first one I wrote, which is called v2wrapper.py. So it makes all the version 2 plugins work. So we can run that's like a central point, is that all the v2 plugins have to work in v3, otherwise we'll never be able to transition. So if you write it for version 2, we can always just use it as is and not even port.
Oh, okay.
But yeah, in a few months. But the version 3, okay. So things that there were many pain points with version 2 that are addressed with version 3. Like if you try to use when you're developing your plugin and you make your plugin and you try to invoke it, and there's a syntax error in it, the error messaging is crap. It doesn't tell you syntax error on this. It just says something like failed to load. So there's all kinds of crappy things like that with version 2. But yeah, I mean, that's what we need to do. That's where the need is. So there's that. There's also Mr. Funk. Is there any way we could get one of the students to help with testing the AM head alert stuff? Would that be something?
I'm not sure really how off the network, because you need a net manager.
Well, no, we don't need a net manager, right? Because they would just run the AM head alert. Sorry, they would run the subscriber with if somebody gave him the scripts, that are in the AM head alert config file? Oh, you're
Right.
saying he would
Well,
compare?
we'd compare. It'd be part of
Oh,
the thing
yeah.
is like you'd run it and compare.
Yeah, so no then. They would need an internal thing.
Yeah.
Okay, so no, that one won't work. So those are example projects, but do other people have other other suggestions? And when we're talking about, so how, okay, Eric von Gravenitz, how close are we to for the students being able to get onto internal systems?
I haven't gotten any feedback on that, but they said about 2 weeks, and that was, well, I guess this is the second week.
Okay.
But I think 2 weeks is a bit ambitious.
Yeah. So my worry is you guys will end up spending 2 months twiddling your thumbs and you'll get access in the last, couple of weeks. So I don't want to wait for something where you have to have internal access. So yeah. Oh, what else? Documentation. We can always use help with documentation. I don't know. Actually, let's flip it around. Tyson, tell us about yourself. What do you want to work on?
Uh, what do I want to work on? Well, I mean, writing a possible that you mentioned for Iridium doesn't seem that bad. I mean, I'm very curious on the more specific details about it, especially the last one you mentioned with Podak.
Yeah.
What could you expand upon that a bit or reiterate the objectives of it?
Okay. Hang on. I'm just gonna. So. Uh, so I am going to Google ODAC. ODAC. Physical Oceanography Distributed Active Archive Center. So we need to get data from here. And what is it? There. Hey, the website changed. Find data. There we go. Find data. And they have this method of select filter. Oh crap! All products. There was a different. Maybe it's data users. Data users. Yeah. So they had using the Podak web portal, using maybe this is it. There was a thing where they talked about. So the thing is, all our stuff is automated. It's not like there's a human who's going to sit there and download stuff in a browser. We want it to work 24/7. We have these weather runs running, so everything is in scripts. And so Podak, they offer this WebDAV, Web Distributed Authoring and Versioning is the name of the protocol. There, that's what I was looking for. So this is what they're talking about. And I don't have credentials. Kurt has some credentials, but if you go in here, like if you had credentials, then you could enter here and you could go and browse this file tree. And it's made accessible using WebDAV. And so if I Google for WebDAV, no, not Microsoft Azure. Okay, well, we'll go to Wikipedia. That's what this is. So it's a way of making folders available. It's a bit like, it's a bit like this, but the way the way our folders work is they're all read only. And I don't understand why they added the DAV aspect on it. I think what they want to do is more fine-grained permissions. But anyways, the way these guys, the Podak people, are making the data available, you have to run a Podak client. And so Kurt set it up where he just starts up a WebDAV as a, like in Linux, you can start up a WebDAV drive, and that's okay for small scale. But like, we don't want, if this feed fails, typically when a file system fails, it just it insults the whole server after that. So we want to have something more confined and less like a file system. Oops. So I think what Kurt was looking at using Python to parse like HTML. I don't think he looked at a Python WebDAV client. So you look at a WebDAV client, and there are a couple of them. So there you go. So I would go look at Stack Overflow and pick one. And so you would write something that would, so you could, Kurt would be your reference. He would give you credentials to connect to the Podac thing. He would guide you. You could set up the Podac drive on your Linux laptop wherever you are, so you could see what the Podac data looks like, and then test your thing by comparing what the Podac looks like versus what you're seeing when you try to do your polls. So yeah, I think that would be easy for a student to do without any internet access, and fairly, a challenging programming assignment. I think it'd be fun. Is that a little clearer?
Yeah. No, it seems really interesting, actually.
Yeah, sounds good to me.
Okay, so we have people thumb wrestling. Excellent. I got vid. So yeah, so those are some. So okay, so that's coding stuff. Is there other stuff people have in mind? So you guys are interested in coding? Like, are you? I didn't get all the background or anything. You guys are CS graduates or CS in?
Computer science students, yeah.
Yeah. Okay. So what are you guys playing with in school? You're playing with Python, I guess, or?
Yeah, we dabbled in Python a little bit. A lot of Java, C++, C, stuff like
Okay.
that. Think of all the ones we've done.
Yeah.
C Sharp.
Yeah. So Java tends to be a lot more verbose than Python.
Yes.
And C++ similarly. They're good. It's just yeah. So
Myself, I'd like to get a lot more experience with Python because I've used it a little bit.
yeah.
To be honest.
So yeah, I mean Python is where there's the most need right now, and even if we don't like writing plugins is there's like a backlog of doing that internally. So there would be like if you guys get through these, if we could ever get you internal access, like there's a server that we're trying to transition, and it's got old plugins versus new plugins. So there's lots of work in modifying plugins to be done, and it's one of the major value adds to our team is that we can do these plugins, so we can give the users the files with exactly the file name they want in exactly the directory that they want, and that's valuable to our clients. So in terms of information sharing, I'm about done. I'm not sure what other people like. What else should we talk? I failed again. What other people want to talk about?
Peter, was there some other testing that you were looking for?
Oh, well, yeah. I mean, so these test suites. So like I said, like this thing, SR tests, is completely V2. So have you guys got any exposure to unit test? And would you be interested in writing tests for the version 3 stuff?
I've had a little bit of testing experience back in, I think, software engineering and professional practices.
Yep.
So there you go. So if there's so in version 2 we have some of the code being tested, but none of that. But writing tests for the version 2 stuff is useless because it's being refactored so profoundly that none of the tests will make any sense. So we could do if you want to, if you had time to do some unit tests, it would be on the V3 stuff. And the first thing to do unit tests of would be the thing that's stable, which is the moth. So like Moth AMQP is done. So if I went and looked at, hang on, I went in back, looked at there. So here I am in V3. If I went, yeah, so Moth is fairly stable. Everything else is in flux. So the only thing you could write, well, maybe the plugin infrastructure itself. If I look, these are the plugins that are V3 so far. And we could have unit tests on them. Although I'm not a good reference for unit testing. I would probably bring Benoit in to talk with you guys about unit tests. He seems to know much more about them. And I mean, you look at these files, and they're all it's modular now. If I look at well, actually, what I should do is just WC minus L plugin /star plugin /star. There we go. So you can see these things. Okay, there's one. The post one is the huge gorilla, but most of them are really small. Okay, no, this is the caching, so it's 400 lines, but none of them are very long. The longest one is the posting one. So unit. I don't know if unit test. So those could be unit tested, and then in Moth there is AMQP. There is these are the two files that have some sort of maturity that would be worth testing. So so unit tests for that would be good. Another thing would be, so we have the when I went into insects, we could add like another like in addition to static and dynamic, we could mirror flow. I started on that, but I don't think I did anything. I don't even think it's checked into the repo. If I do git status, is it mirror flow is not there? Yeah, so it's I started it and I don't have time right now. Adding a so this is a use case where you have to build a complicated the mirroring test case. The mirroring test case is I can go and it's on the website. The mirroring test case. It's one of our kind of star clients. If although they're not very happy with us. Nope, that's not where I'm supposed to be. There. And there's something mirror or something. It's not called mirror. Mirror. Oh, HPC mirroring. There you go. So here's the problem. We have two supercomputers. They have two very large SANs. We have a tree of 27 million files approximately, and we want them mirrored in real time. And so this is where we use the C code. And we're using a shim library. Does anybody know what a shim library is? Probably not.
No.
So it's a hacker tool. So what you do here, there we go. So when you build an application, it has you have DLLs in the Windows world, and in Linux they're called shared libraries or shared objects, so SO. And so you have your application, and at runtime, when the binary is loaded, you make dynamic links to all the libraries that you need to use, and there's like a path to it, so it goes at them in sequence. So when you look for, like in this picture, you guys can see the picture. I've got shim library. You guys can see this. I hope I'm sharing the right.
I got it.
So you see there's a close call, and the application says close, and then it goes and it'll look in the path, and it'll look in libssl.so first, and then libc, and then libm, and the first one it hits will be the one it uses. And so what we do to do a shim library is we make we put a fake library of our own in front. So when they invoke close, it actually uses our close. And when our close runs, it'll make a post. It'll do an SR post. And so that way, all the users run all their normal code. There's just this modification to the environment, and every file they write gets posted. And then we have subscribers on the other end that subscribe to the posts and copy the files over. And when you're dealing with 27 million files on 1,000 nodes, this is the most efficient, the most practical way to get it done. And we've been working for like 4 years on this now, and it's close to done. But how do we get here? Oh yeah, so the idea would be to make a test case that just we have that in the dynamic flow. There is a little bit of test of the shim library in the dynamic flow test, but to make something more contained that just tests this and isn't mixed in with other use cases, and try to glorify it to add some more behaviors. And as we find issues that the client reports on, what we want to do is run different pieces of code that write files in different ways and confirm so that would be another like a use case integration test that would be nice to add. And I'm out of time. So that's an example of another test case. If somebody has other ideas of other kinds of test cases that we could add to insects, that would be great. More tests are good. So, whoa, what did I just do? No, there in insects. Yeah, so it would be adding a mirror directory here and having that explore the mirroring use case in more detail. But that I don't think you could get that done in a month or two. Okay, so that's another project. So if you need like a reference for the Python code and like advice or something, you can ping me. I guess you guys don't have Teams access, so Rocket Chat is fine. I don't pay that much attention to it, unfortunately, but you can try. If somebody's working on Podak, I think Kurt is the natural lead for that. For the Iridium stuff, it could be anybody. It could be Mr. Funk. It could be Jin. It could be Noradzin. That's a straightforward one, I would think. Yeah, I'm running out of stuff to say.
So, Peter, what about we pause or call it a day soon?
Yep.
And then you can share out the video.
Yep.
And the students can watch that again, think about it, and investigate a bit.
Yep.
And then we maybe regroup again on early next week.
Sounds good.
Next week. I might have I'll try and get an answer on their access.
Yeah. And if there's these are just suggestions that come to mind readily, and if there are other ideas, and if other analysts come up with other ideas, sans mille à l'heure. I guess that's not useful in this audience. Go for it. All the expressions I'm coming up with are in French for some reason. Yeah. There's lots to do. But yeah, a lot of the other projects would require internal access, but I think these are fun. And we can find something that would look good on your resume if you're not happy with us, and that will still help us, and win-win-win. So yeah, with that, I'll close off the thing. Does anybody want any like final remarks or?
We're good here.
Thanks for hosting this, Peter.
Yeah, thanks. It's been awesome.
Okay.
Yeah, thank you very much.
Okay. You're welcome. You're welcome, and we'll talk next week.
Sounds good.
Okay.
Bye.
Guys.
Okay, hold on, I'm gonna put my ears on.
I turn this off. Okay, end meeting.
Okay,